Now let's take what we learned with those examples and put it into words and be able to take that information and move it forward. So here it is. The mean and standard deviation. So based on the fact that we have a sampling distribution here of x bar, all right? This means, suppose that a random simple variable of size n is drawn from a population with a mean and a standard deviation. The sampling distribution has a mean that's equivalent to the mean. So the sample mean, notice that, I'm going to write it over here. Over here, I'm going to put it in red. So we know that our sample mean, so look at the symbols. The mean of x bar, meaning the sample mean, is equal to the population mean. That's what that stands for. The standard deviation of the sample, that's where this little x bar comes in, because they're talking about this sampling distribution, right? About that mean, those different means, is standard deviation divided by the square root of however many are in those samples. All right? The standard deviation of the sampling mean is sigma x bar, called the standard error of the mean. So this is called the standard error of the mean, the same thing as the standard deviation. Oh, doggone it. Sorry about that. The same thing as the standard deviation of that sample mean. All right. So here's a little note that we're going to make right here. Regardless of the distribution of the population, regardless of the distribution of the population, all right, the sampling distribution will have these two pieces of information. The sampling distribution will have this. The mean is the mean, and the standard deviation is sigma divided by root n. All right, so that's the deal. Regardless of the distribution of the population, when I'm talking about the sampling distribution, here is the criteria, or here's how we figure out the mean and standard deviation. And as soon as you know the mean and the standard deviation, then you can start coming up with probability, proportion, area under the curve, right? All of these things that we've talked about previously are now going to come into play here and now. So check it out. The shape of the sampling distribution of x bar, if my variable is normal, right? If we have this as normal, if the random variable x is normally distributed, the sampling distribution x bar here is normally distributed. Here's the deal. Did we not literally just see this? Here's our population, is this nice sweet bell curve. Well, the mean, I'm going to make this bigger so we can see it better. The mean here is the mean, right? So this is whenever n is equal to 9. So we saw this previously, right? N here is equal to 9. So if I'm going to have my mean as the mean, it was still 100. But what happened to my data? That standard deviation was smaller and it became real tight in there, versus the standard deviation of the population was more spread out. The mean was the same. It's just my data was not as varied with these samples. All right, so that's where we're saying the mean is still the mean, even of the sample, and we saw that on the other two with those same characteristics, right? The center was the same. The standard deviation, however, changes because depending upon the sample size, depends on how spread out my data is. Do you see that? Okay, now let's do an example here. So, if IQ of a certain number of humans is approximately normally distributed, that's important to know, with a mean of 100 and a standard deviation of 15, that's our population, right? Compute the probability, proportion, probability, area under the curve. We learned all of this. That a simple random sample of size n equals 10 results in the sample mean greater than 110. So greater is that symbol that we're looking at. Now, you need to, let me squeeze this down a little bit, you still need to use these two formulas. In order to find a probability, you have to have a mean and a standard deviation. So we need the mean here of x bar and the standard deviation here of x bar. So the mean is the mean. If the mean of my population is 100, then my sample mean is also 100. Good. I don't have to do any work for that. Woohoo! However, my standard deviation is going to be sigma divided by the square root of n. So my standard deviation is 15 divided by the square root, and in this instance, my sample size is 10. So plug that into your handy dandy calculator, and what do you get? Oh, I don't know, 3 decimal places. Let's go there. 4.743. There's my standard deviation. There's my mean. I'm going to make this bigger now so that we can see it better. My goal is to find the probability here that x bar is greater than 110. All right, so this is going to be which area? If it's greater than, is it going to be to the right or to the left? It's going to be to the right. So let's just do a little graph over here. If I know, wow, that's terrible. Let me not make this little fellow quite so tall. I don't know why I put him in there first anyway. Right? So I know this is 100 and I'm here at 110 and I want this area, right? Greater than 110. That's the area that we're talking about. Okay. This is the area to find. So I know it's that greater than situation. So let's hang into StatCrunch. It's still normally distributed. So I'm going to go to Stat, Calculator, Normal. Same thing that we have been doing this whole time, right? We've started in chapter 7. And then this is if we're just a plain z-score, but we're not. We have data that we're looking at. So type in your mean. It is 100. Type in your standard deviation. And this is where you have to do it as a decimal. StatCrunch isn't going to take a radical. So 4.743. And then this has to be greater than. It's okay that it says greater than or equal to. Because it's going to compute the same thing. What are we going with? 110. And then we have to see, here's our area and here's our probability. So scoot this in. Then we're going to go to, I don't know, 4 decimal places. So the probability is 0.0175. 0.0175. All right? So the IQ, oh, hang on. Therefore, the probability of obtaining, let me scoot this over. Now that we have that, we don't need to see that anymore. Of obtaining, oh my gosh, I got to learn how to spell. Obtaining, I left out a couple of pieces to that word. The probability of obtaining an IQ greater than 110 is 0. I'm just going to write 0.2. Just because I'm rounding. So the probability of getting over 110, 2%. Do you see that? Like if I were to move this 2 over, 2%. Not good, right? That is few and far between of the probability of getting an IQ greater than 110 is definitely a minority. Very few would make that happen, right? And let's just talk about this real quick. Would it be unusual? Yeah, because remember the concept of unusual here has to be less than 0.05. That is. So that is statistically considered unusual. So see, it's always nice to bring in previous information into the current lesson. I love that stuff.